Hi! Back in October of 2018, I published a video that featured and talked about the history of the NuTone 313 series. In that video, which I'll link one of those pop-ups up here so you can go watch that also. In that video, for the real master station that I had, we used an IMD313, but I spent some time talking in the beginning part of the video about the 5 different versions that NuTone had made of the 313 and how the earliest version, the original IM313, had a very unusual style of clock on the master station. I didn't have a 313 for that video because they are kind of hard to find. The only thing I had, which was this. This is the service manual, and I used this picture to sort of illustrate what I was talking about and so forth. Ever since that video, I've been on the lookout for an IM313. And they don't come along very often, and sometimes when they do come along, they're priced way, way, way more than they're really worth. You gotta sort of pass on that. Recently, I found an IM313 that was reasonably priced. And so I went ahead and snatched it up, and here we have it today, and I thought I would do a brief video about it. Now, this is not going to be a rehash of all the information in the other video. This video is really going to be all about the clock, because these have a certain specific unique style of clock that was only used when these first came out in the IMs and the IMAs, I'm pretty sure. And they're unusual, and it's an early 70s kind of thing. The actual opening of this video, you were looking at another dial of this type of clock, and that was a LumaTime clock with neon lit digital numbers. However, it's not actually a digital clock in the sense that it's not LEDs, it's not driven electronically by some kind of controller or something like that. It's actually a mechanical clock that's operated or run by a motor, but it has digital numerals that you see when you go to look see what time it is. So technically it is a digital clock, but not in the sense that we talk about today. And this is a very early 70s idea, because it was in the mid 1970s when the 8-segment red LED display blocks were first introduced and became widely popular, and everybody was buying, clocks with LED readouts on them and so forth. So this is before that time. Let me go ahead and show you this clock looks like when it operates, and then we're going to do kind of a little clockectomy out of this unit so I can show you how the clock actually operates. Pretty interesting, huh? So here we're looking down at the back of our IM313, and let me just briefly explain to you what you're looking at, and then we're going to get on with it. Here we have the speaker cone. This is the radio intercom chassis assembly. You have an AM/FM tuner, you have the talk listen module, the amplifier and power supply is down here where it's a little hard to see right now. You've got on-off volume control, some auxiliary audio inputs, intercom control switches, some system-wide adjustments here, and under this big silver can is the cassette player. This portion right here is the actual clock, and up here this board is referred to as the message board because you can leave messages on a cassette tape because it is a player and recorder all at the same time, and that's kind of what we're looking at. 313s, just very briefly, are a version of an IM303. If you remove the cassette player, the clock, the message board, and move the speaker over here and shrink down the faceplate, basically what you have is an IM303. It's an enhanced version. What we're interested in today, what I'm most interested in, is this clock assembly. Now, in the service manual, the way it's described under the heading digital clock, you have 3 possible parts, or perhaps it's 4. You have a complete clock assembly, which it would be the whole thing. You could have ordered just a replacement motor, which it says supplied with complete clock mechanism. You can order the 2 lamps, they're GE number 161s, and you can buy this big 5-watt resistor. Those are the only parts. So it's pretty certain that this clock assembly was not made by NuTone or designed by NuTone. It came from a vendor and they incorporated it into this design. What I want to do is I want to remove this so I can show you how it actually works. So what we're going to do is we're going to remove it. So we'll take this twist tie off, and no, I haven't actually taken one of these apart before, at least not that I can recall. We'll move these out of the way. We're going to try to do this as carefully as we possibly can because I don't want to wreck it. This may be the only one of these that I find, at least at a reasonable price, and it would be a shame to have it go to waste. So we'll take these 2 screws out and remove this metal shield. Not exactly sure why we need the metal shield, but somebody at NuTone thought it was a good idea. I don't think it would have anything to do with shielding noise from the motor or something like that. And that gives us a little more slack on our wires, which is always good. We always like a little more slack on our wires. These 2 white wires that are attached to the coil of the motor go down here and are wired into some spot underneath part of the board. So it looks like we're going to have to remove the talk module to see where they go. Of course, it disappears and disappears and disappears. So what we're going to do, one of them goes down to one side of the on-off switch, so I'm guessing the other one goes down and ties into something. The clock gets constant power whether the master station is on or not. This is the type of design that when you turn the master volume control on-off switch all the way down and click it off, all of this is truly off. But the clock still has to have power because it has to run all the time. So what we're going to do, just to make life a little simpler, is I'm going to clip off these wires right here where they're soldered onto the terminals of the coil, because they're plenty long enough and it's easy enough to solder them back on, instead of getting down into this mess to try to figure out what's going on. And that's easy to put back. So it looks like this is held in place with just 2 screws. I remember long time ago, the very first time I ran across one of these on a service call at a customer's house, and it was unusual and hard to figure out how this actually works. So here we have our clock mechanism. Let me go ahead and move the master station out of the way so we can take a look at this. So here's our clock assembly, and as you can see, it's pretty grimy. So before we do anything else, I'm just going to lightly sort of brush off some of the grime. One of the things you might have noticed when you were watching the introduction to this video with the LumaTime clock, the one with the neon lamps in it, not all the segments lit up correctly. The LumaTime clock I actually picked up a year or so ago at a local neighborhood sort of flea market kind of thing, and the guy had it on the table, and I asked him if it worked, and he said he didn't know. So we wandered down the street to a local business, and it was in a shopping center parking lot, and I asked them, could I plug this in for a second? And they said, yeah, I guess. So I plugged it in, and it did light up. Unfortunately, not all the segments light up properly. These things are so incredibly complicated, I can't even tell you. Anyway, back to the NuTone assembly. So we have this sort of diffuser here, and it looks like it's simply held on. There's some tape here, and there's some tape here. So I'm going to go ahead very carefully and just sort of cut through the tape, because that may reveal some of the interesting bits. This. And this is kind of interesting because it's an opaque plastic, but on this side there's sort of a hash mark texture. It's angles this way and angles this way scored into the plastic, and I think that's to help diffuse the light that comes through when it's lit up, and probably gives it more of a futuristic kind of look. And then we have, what we have here are, we have some cutouts here in the plastic, the chassis of it, and if I look at this really carefully, they're just cutouts. There are things behind it, and I'm going to try to show you what those things are. But of course, these are complicated, and you have to be really careful with these. So there isn't anything in the service manual on how to work on this, because I don't think it was intended that anyone actually work on them. It was an assembly, and if you had one with a problem, either you could buy a motor or you could buy the whole thing, and that tells me that it's beyond what most people could reasonably do. So essentially what you have here is you have a cutout here, which would be a 1 when it's lit up, and then you have your pretty standard 7 segment cutouts. The 7 segments would be 1, 2, 3, 4, 5, 6, 7, and these are the same sort of pattern that are used on 7 segment LEDs, because that's what the 7 segments is, what you need to make numbers show up that look like digital numbers. Then we have another piece of plastic here that's held on with 2 screws. So we're going to go ahead and take this apart and see what we've got underneath. Now this particular IM313, it was made in March of 1975. It's got a date stamp and it's got a manufacturing code stamp, and they both match up. And if we take this out carefully, we might be able to see something interesting. There we go. So this is just a plastic cover. It's got some grooves and ridges on the back, I think to help hold things in place and also to make it sturdier. And in here we have part of the assembly. This little knob right here is the knob that you use to set the clock. And according to the instructions, which we should look at here, there are instructions in the service manual. It's on page 5, number 3. Using the time set control, set the clock to the correct time. Push control in and turn counterclockwise, advancing the minute digit and the hours digit to the nearest the correct time. That's actually what it says. I don't think we needed the in there. With control out, turn counterclockwise, advancing the second minute digit to the correct time. Apparently this was written either by some engineer who had never done this before, or perhaps these are the instructions that came with this from its manufacturer and it didn't translate that well. So if we follow the instructions, if we take this and we pull it out, and we have to be careful because now all these little gears and things are not really being held in place, and it's hard to do this so you can actually see, but if I pull this out a little bit and turn it counterclockwise, it turns this gear clockwise, and then if I push it in and turn it, it turns this gear, which turns this gear, which ultimately turns that gear. This gear is interesting because molded into the gear, and I believe it is a plastic gear, I think they're all plastic parts, molded into it, you can see it's got hour numbers on it. It says 3, 6, 9, and 12. This is probably what is necessary. You have to, when you assemble all of this, you have to assemble it in the correct order so that it makes the correct time at the correct time. This is very complicated. And see, now the little set knob fell out, and there's a little tiny spring that apparently was underneath it, and it fell out also. And the key thing is now, oh, and there's a washer also. So I think this goes in there, and the little washer, there it is, and this goes on here. Alright, so what we're going to do so we don't mess this up is we're going to put the cover back on, because I have played around with the Lumitime clock, and I can tell you from first-hand experience that it very simply could drive you insane trying to reason your way through all its complex mechanical parts when you have no manual or drawing or diagram. And also, it's one of those kind of things that just when you think you got it figured out and you got it working properly and all the segments light up, then you put it all back together and it does work. So there's that. The real money's on this side. So we have the motor here, and this is actually very much, I believe it may be a Telecron motor assembly. It says GE on it, so that's sort of a giveaway there. It's got the little gear drive assembly here like you would see on a Telecron motor drive assembly. So I think the prudent thing to do would be to remove the motor first, if for no other reason, because it eliminates a lot of bulk and weight off the thing. Which will make it easier to deal with. Of course, we've got one wire that goes from one terminal on the coil over here to help light up the lights, and then you've got the resistor that goes over here, and you know, there's always something that's in the way. The resistor is to drop the voltage to the lamps so they don't burn as brightly. That's sort of a typical NuTone way to deal with something like that. It's very simple to do, and with a 5-watt resistor, it's never really going to be much of a problem. Now I am trying to figure out if it's reasonable to take how much of this to take apart. I do want to show you, so we can take this screw out and remove the lamp assembly with the motor. Put that off to the side. See, there's the little gear drive assembly and the little output gear on the bottom of it. So we'll put that over there. I'm just investigating right now. Alright, so let me do something here. This is pretty dirty, so I'm going to get rid of some of this. And then do this. That'll make it a little easier. And I'm going to try to show you this before we get too deeply into it. So if I tilt it down like this, you should be able to see there's a lever right here. It's hard to do this upside down. There's another lever right here, and there's a third lever that's over here, right here. And those levers on the end of each one there's a little cutout, and they fit around these little black plastic pins. And when you turn the knob, watch the levers, you can see them move. And that would be turning it clockwise, and then if I pull it out and turn it clockwise, it turns what would be the minute numbers. And what that's doing is it's moving masks that are between this part here, this part, and you can see the light shine through. In fact, if you do it this way, if I shine the flashlight through it, see, you can see the light shine through the cutouts. So the masks move around and they let the light from the two lamps in the lamp holder here glow through, and that's what makes it show numbers. This is very complex, and I am a little concerned about taking it apart because, again, I did play around with the Lumitime clock, which is different than this, but also equally complicated, and was not very successful at fixing it. And like I said originally, I don't want to wreck this if I can keep it all in one piece. Well, let's take a quick look and see what we might be able to do. So let's go ahead and very carefully, now this may all go horribly bad here. So I'm not sure how something like this was ever designed in the first place. I'm sure whoever came up with these ideas, they were all some sort of mad geniuses. Because something like this, I think most commonly belongs in the same world as slot machines, pinball machines, and jukeboxes. Okay, so now, like I said, this could all go horribly wrong, or maybe it won't be that bad. We'll have to wait and see. So here, I'm going to try to be really careful and not move things around. This is the back side of the plate. So here are the three arms with the notches that fit around the pins that move the masks. And here we have a gear assembly with sort of a cam on it. And these actually, these levers, they come down like this and then move to my right. And there's actually a pin on each one. And we'll set that down carefully. And then we'll look at the back of this. And see, this is the magic here. So what we have are these cams, 1, 2, 3, with these oddly shaped, squiggly cutouts in them, these grooves, and the pins on the levers here fit into the squiggly grooves, and as these turn, they move the levers in the right direction and make the masks move. There's this here, which I couldn't tell you what it is, and there's another lever here, and again, we're not going to mess with this too much. There is a lever here that has, so on the outside of this cam and on the outside of this cam, there are large teeth, which you may be able to see around it. This is one right here, and there's another one here, and I assume that they're spaced reasonably equally. However, like here, there's this large section right here where there's no tooth at all, but there's a locking part here and here that would fit into the teeth. So somehow or another, when these turn, this must rock back and forth, and at some point this pushes this one and pushes this one down, and then it does something, and then something goes round and round and round, and then something else happens. That's a technical definition of how it actually works, because you could actually study this for a really long time, and maybe eventually you might be able to figure it out. This is all entirely, this is what would be referred to as mechanical logic. There is a logic to how this works, and the grooves in the squiggly grooves in the cams with the teeth on the outside and the levers and all this other kind of things, it's a program. It's a mechanical program that makes it work a certain way. On the back side here, you can see the back of the 7 segment cutouts. Then you have these metal or these plastic pins that stick out, which fit in the slots in the other arms on the back of the metal plate, and that's what moves the masks around. And because I'm going to be a chicken today, I'm not taking this piece out. This piece is held on with, there's like 7 screws. And if it wasn't for this assembly right here, I might be tempted to do that. But I'm concerned that if I take it apart, I'll never get it back together. So that's really as far as we're going to go with this. Now the trick is, can we get this back together? And see, you get to watch me try and struggle with this live. Unless, of course, you're watching this after I've recorded it, and then it's not live. That's a bad joke. Ha! Is it all in place? It all seems like it's in place. It also all seems like that was way too easy. And oftentimes, when things seem like they were way too easy, that's because you've missed some small but critical and important aspect of the whole thing, which see, it seems to be hanging up on this side a little bit. And the metal plate is not, there we go, snap. And as I pointed out, I don't know if you heard that or not, as it clicked into place, not due to any cleverness on my part, merely a little bit of dumb luck. As I quoted in another video, that would be the click of success, where it clicks into place, it's seated down correctly. Don't push your luck. Just put the screws back in and consider yourself lucky. There's 2. Now, I'm pretty sure. Oh, and here we have a sticker, actually, right here. And if it focuses, maybe you can read it too. It says Telecron motor rating 18 volts AC, 60 cycle, 3 watts, movement made in USA. It's a Digitel, and it has a number of JG0103H, and then it says 743. So I'm pretty sure the 743 would mean a manufacturing date that this was manufactured, or at least the motor was manufactured, in March of 1974. Was this whole thing made in March of 1974? Possibly. Is this actually a GE Telecron clock assembly? Possibly. That will require some further research. So now if I turn this again, it seemed as if things move as they did before. At least I hope they did. Yeah, I think it's pretty good. I think one of the problems with this may be also it's really, really dirty. It looks very grimy and oily inside, and I don't think that helps the plastic parts move well at all. But we're not going to tempt fate. So we've got that back together. Let's go ahead and put the cover back on. We'll have to get a little tape to hold it in place. And we need to put our motor and our light assembly back in place. Let's see. Like that. This goes back on here. And I think the best thing to do at this point is we should power it up and see if it still works. Or maybe it works better than it did before. I don't know. So I'll tell you what. Let me go ahead and get it set up, get some power to it, and I'll be right back. Alright, let's go turn the power back on to it. And it lights up. It's 12:17. Actually, it's not, but that's what it shows. I think, and for you folks at home watching this, this is much brighter for you than it is here for me. This piece of plastic obscures the light quite a bit, and if we take this off, let's see what we get without it. So without it, you don't really get much at all. You can see it, but I think with the cross hatching on this, it helps diffuse the light somewhat. And it's an important part to make it be able to read it better than without it. I think the other thing that could be done on this, in my opinion, this is rather dim, especially compared to the LumiTime clock. Now the LumiTime clock, it has neon lamps, and neon lamps put out a lot more of a nice orangey glow look than incandescent lamps do. And also it could be that these lamps, these 161 lamps, they're being operated at a fairly low voltage for them. 161 lamps I think are 28 volt lamps, and this is only operating on approximately 16. So actually if we measure the voltage to the lamps, they're only running at 8 volts, which is fairly low. And I have a feeling the reason they did that was two things. One, the lamps will probably never burn out because they're running at such a low voltage. And also, when you run incandescent lamps at a really low voltage, you get sort of a nice orangey glow out of it. And this is, it's not terribly orange, but it's very amber. How about that? It's an amber colored clock, and I think that's probably the look they were going for. I have a feeling that you could probably put in different lamps, or you could play with the resistor and brighten it up a little bit, and that would make it easier to read, especially from across the room. But I don't think that there's enough of these around anymore that too many people are actually worried about it. It's just an interesting thing. As near as I can tell, not only for NuTone intercoms, and there we go, we have changing time. It's now 12:20. This idea of a mechanical clock with a digital readout, and see, you can see here, this is supposed to be a 2, and the center segment here is not really lit up. So there's something about the mask that isn't quite right. Oops. So if you reach in there, stay in place. So if you reach in there and you wiggle it, oh, so see, my finger was blocking the glow of the bulb. So if you reach in there, see, here's the screwdriver. See it move up and down the shadow? That's what happens when something gets in the way of the light. So if you move the mask, you can't really move it by hand. You can sort of wiggle it back and forth a little bit. So I'm not sure why the center of the 2 doesn't show up very well. See, now we just changed to 1 here. Anyway, by the time you get to the mid-1970s on most products, you know, or 75, 76, 77 certainly, even the Lumitime company, the one that made this, they switched over from this style to actual LED readouts with 7-segment red LEDs, and they made a lot of these. Some of these sell for a lot of money. I've seen some. There's a wall version of this. It has really big numbers. The numbers are like 8 inches tall, and a new old stock one in working condition, you know, people are asking $400 for it. So these are a blast from the past, but they ran their course. I think probably the cost to manufacture was a lot higher than just putting a 7-segment LED with a driver in it. By the time you get to the IM313s, they had 7-segment LED clock assemblies, and those clock assemblies actually were made by, it was a little module, and they were actually made by Texas Instruments, and it was just sort of a generic LED clock module. It had a driver, and it was all on one board. And again, NuTone chose to use that. They incorporated it into the design of the faceplate. It had buttons on it to set the time and so forth, and that was all incorporated into it because it was just easier that way. It's a lot smaller than this. It probably was not any more expensive, or even was a little bit more expensive. It certainly was easier to deal with, I have a feeling. That's sort of a look at the unusual style of digital clock that's in a NuTone IM313 from 1975. I hope you found this interesting, and maybe for someone it will be helpful. And if there's anybody out there who is an expert on how these things actually go together and how you service them or something like that, leave it down in the comments down below. I would be interested. I'm still working on trying to fix this. It's a nightmare to try to figure out, and it's got all these. This is a lot more complicated than this is, because this has all the little gears and cams and so forth, and they turn discs, and on those discs are little copper fingers, and the copper fingers make connections to light up each individual neon light. So there's 7 neon lights per digit, and they're all soldered onto a circuit board, and the neon lights actually individually are switched on and off to make the numbers. It's very complicated, and it's really hard to try to get all the fingers to touch correctly, and that's why some of the numbers seem to flutter. Anyway, if you found it interesting, give it a thumbs up. That helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.